All right, let's compare the square root of 9 times the square root of 4 versus the square root of 9 times 4. All right, so this first example, the square root of 9 is 3. The square root of 4 is 2. And so that answer is 6. For the second one, we have to do what's under the radical, and that's your square root symbol. So that would be 36. And the square root of 36 is 6. They're the same thing. Okay, so we can break apart square roots into two separate square roots to help us simplify them. So let's take a peek at the square root of 400. Square root of 400. All right, I'm going to break that up into the square root of 100 and the square root of 4, because 100 times 4 is 400. But the square root of 100 is a perfect square, and the answer to that would be 10. And the square root of 4, sorry for that, is 2. So 10 times 2 is 20. Okay, let's try another one that doesn't simplify to a integer. All right, let's say we have the square root of 75. All right, I'm going to try to think of two factors, but I want one of them to be a perfect square. And by that I mean, okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So these types of numbers here, one where we could take the square root of that number. Well, 25 is a factor of 75. So I'm going to break this one up into the square root of 25 and the square root of 3, because 25 times 3 is 75. Well, I can take the square root of 25, that's 5, but I can't take the square root of 3, but it's still being multiplied by it. So I could simplify it to 5 times the square root of 3. All right, let's try another silly one. All right, let's try the square root of 32. So we can break that up into the square root of 16 and the square root of 2. The square root of 16 is 4, and there is no square root of 2, so we're just going to have them together. They're being multiplied. So 4 times the square root of 2 would be that final answer. Let's try the square root of 700. We could break that up into the square root of 7 and the square root of 100. The square root of 100 is 10, and there is no square root of 7. So our final answer would be 10 times the square root of 7. We put the integer number first, followed by the square root. Here is a second method that you could use. So let's say we have the square root of 288. I don't really know what that's divisible by, so I'm just going to break it up into some other numbers. It's an even number, so for sure it's divisible by 2. So the square root of 2 times 144. Now 144 is a perfect square, but maybe I just don't know that one because that's kind of a tricky number. So I'm just going to keep on making a factor tree. I could multiply the square root of 2 times 50, 60, 72. Okay. And then square root of 2 again, because that's even. Half of 70 is 35, plus 1 more is 36. Ooh, yay. I know the square root of 36 is 6. Okay, so that one's 6. But now if I have something here and something here, together, that's the square root of 4. So the square root of that is 2. So basically, if you have 2 of the same thing, it would be that number under the radical. So that's where the 2 comes from. And then we have the extra 2 here. So we have 6 and a 2 and a square root of 2, making that final answer 12. Oops, I don't really need that times symbol there. 12 square roots of 2. All right, last example. So here's another silly one. All right, so if I'm going to factor this, it ends in a 5, so I know it's divisible by 5. And then, let's see, if I put that into a calculator, my other number is 441. Yuck. Now, if you were to add up all of the digits, so 4 plus 4 is 8, plus 1 more is 9. If the sum of those digits is a multiple of 3, you can divide it by 3. All right, so let's divide that one by 3. We get 147. Another yucky number. All right, I'm going to see if I can add those together. 1 plus 4 is 5. 5 plus 7 is 12, which means we can also divide it by 3 again, because 12 is a multiple of 3. And then we get 49. Ooh, and I do know the square root of 49, which would be 7. Since we have 2 of this number, that means 3 would be another number to use. And then we still have that square root of 5. So that final answer would be 21 times the square root of 5.